Hello. So in this video we're going to be looking at the first of three rules for differentiation, the chain, the product and the quotient rule. So we're starting with, as you can see, the chain rule. So the chain rule is used when you have a function of a function, and it's written as shown: dy by dx equals dy by du times du by dx. Essentially that obeys the rules of fraction multiplication, so the du's would cancel out and leave with dy by dx. So the idea is that we write y as a function of u, where u is a function of x. Both of those we differentiate using results we already know. Now it's possible to extend the chain rule to more than two parts, okay, but we're going to start off with two-part chains. So imagine that we've got y equals cos x to the power of 6, which we write like that, cos with the 6x. So we can rewrite that as y equals u to the 6, where u is equal to cos x. And then chain rule there at the bottom left says that if we want to know what dy by dx is, then if we can work out dy by du and du by dx, we can simply multiply them together. So we've got y equals u to the 6, so dy by du would therefore be 6u to the 5 times by the index and subtract 1 from the index. And u would be cos x, which we've learned in a video previously, gives you du by dx equals minus sin x. And then we times together the dy by du and the du by dx, and we've got the minus 6 at the front, and then the sin x, and then u to the 5. Remember that u is cos x, so that's cos x to the power 5. So the final answer for dy by dx is minus 6 sin x cos x to the power 5. Now we're going to look at a chain which includes the exponential function. So y equals e to the power of 5x to the 7, which we can rewrite as y equals e to the u, where u equals 5x to the 7. dy by du is e to the u. Du by dx is 35x to the 6. And again, if we multiply those two results together, we get e to the u times 35x to the 6. Remember that u is 5x to the 7, so we can rewrite it in this order as 35x to the 6 times e to the 5x to the power 7. So a final two-part chain, this one with a logarithm in it. So y equals ln x squared plus 3. So we can write this as y equals ln u, where u equals x squared plus 3. dy by du, as we've seen in the previous video, would be 1 over u. Du by dx is 2x, and when we multiply those together we get 2x over u, and we know that u equals x squared plus 3, so dy by dx would be 2x over x squared plus 3. So just like you can multiply two fractions together, you can also multiply three fractions together. So at the bottom left of the screen you can see it says dy by dx equals dy by du times du by dv times dv by dx. And again, the du's and dv's would cancel out, so it works mathematically using fractions. And so we've got an example here of y equals the square root of e to the 2x squared plus 1. We can't do that with a two-part chain, but we could say if y equals u to the half, where u equals e to the v plus 1, where v equals 2x squared, that is how we can make that function. And we can differentiate each of those individually. So if y is equal to u to the half, then we can times by a half and take away 1 from the index. So dy by du is a half of u to the minus a half. If u equals e to the v plus 1, then du by dv is equal to e to the v. The 1 of course just vanishes. And if v equals 2x squared, then dv by dx equals 4x. And then we can multiply all of those together. Half of 4x is 2x. So we'll have 2x e to the v on the numerator, but remember v is 2x squared. And then on the denominator, because it's u to the minus half, we'll have u to the half, which is the same as the square root of e to the 2x squared plus 1. Finally, I'm just going to notice something that, to be fair, we have already used in the e to the x and ln x video, that dy by dx is the reciprocal of dx by dy. So for example, if you were asked to find dy by dx in terms of y, and you were told that x equals y squared plus 2y, you could start by working out dx by dy by differentiating, so 2y plus 2. And that means that dy by dx would simply be the reciprocal of that, which is 1 over 2y plus 2.